I made this screenshot when I put all the movies that I created for this project in my movie editor, and this is how many hours, yes, those are hours, 8 hours and 41 minutes, almost 9 hours of raw filming. And I had to compress everything to be watchable, because nobody on this earth, not even me, can rewatch all those 8 hours of actual making everything. But I wanted to share with you how long all this project was, the making of it, the making of this board. Actually, it took a little bit more than this time, 2 days I believe it took me, but I did work non-stop. So that's only a fragment of the entire time I spent on it. Just to keep in mind, nothing on this earth is simple. Although it's looking like it's simple, it is not simple. Nothing is simple. All right, so this is the circuit diagram that I finally made it at the very end of the entire thing, after I constructed everything, after I built everything. Right now I am in the editing process. So I'm editing the movies that I recorded. So this is the circuit for doing all the rotary encoder stuff. This is the ATtiny microprocessor or microcontroller. This is its output. These are the in-circuit programming wires, and these are the data wires that this microcontroller is listening to them and outputting, processing them and outputting whatever the correct answer is needed. This is it. This is all the circuit in its glory. All right, this circuit where I model it in my favorite 3ds Max 3D environment, including all the wires and everything, and I just basically copied in reality. I checked and double checked and triple checked both circuits. I am combining 2 circuits here. In-circuit serial programmer for the ATtiny44 using Arduino Uno. This is the setup of programming this chip using Arduino Uno, and here is the rotary encoder circuit that I link it exactly as I'm having it here on the breadboard. It worked from the first try, actually. So that's it for the 3D presentation of the circuit in all its glory. I hope you like it. Thank you very much. That's it. My second chip from this batch. The first one was for testings. This is for actual using. These chips have very shitty marking. It is having a dot there, but it's almost invisible here in the middle, as it should be, like that. It's just an indent to know the position, the pin position, because it's having a tiny circle there, but it's so tiny you really confuse it with with the background. Now I will change the tip, and I have this very good one. I had to adapt it to this one because this was not meant to work with this. I drill it here to enlarge the hole to fit this cylinder here. That's what I did, and I did some other experiments, but it didn't work. And it was actually more longer, but I fucked it up. Now it's a little bit too short. If it's having enough strength here to hold it, it's very good. I have a new resin holder, but the resin is the old one. I had it in a white plastic box, and now this is a metallic lid actually from some bowl. I melted the resin that was before in that plastic container and I put it here, and it's still looking black. It should have been more transparent, more yellowish. So it's brand new right now at this point. Let me actually prepare the pins. Actually, I can push it that way. When it's catched in only one pin, you can move it a little bit. And right now, I'm completely secured here, soldering from opposite corners. I have two pins that are bent. That one and this one, and another one here. Oh, yeah, it's good. Yeah, I'm not sure preparation is a good idea, like I did before, like I prepared all those pins before, because it is adding a little bump under the pin, and when you put the chip here, it's staying on those bumps, and is like that. It's not that good. It's not a very big bump, but it is a bump, and I hope they have a little blob of solder under the pin. Ideally, that's what I'm imagining, but in reality, who knows. Okay, the chip is on. ATtiny44A is mounted. Oh yeah. Now I'm checking if I mounted it correctly. So that is 1, 2, and that is 1, 2. And this is the notch here. It's not very visible. Like that. Let me make it more visible there. Yeah. Good. It's good that I wasn't stupid to mount it inverse. I did check it, but for a while I lose track of the numbering there. And now, this is a picture from my 3D view. And this is a little bit, yeah, I can actually zoom in. This is a very strange shape. It's a very nice shape, but strange. It's strange to make. I probably have to actually do it right now, better than later. And I think I know how to do it. Okay. So what I need to bend it first here in the middle. Let's see. Something like that. So this will go underneath, and they will form this shape. It's a bit hard to make it, to be sincere, but it is possible. So I should make it now better than later. So I will enlarge with a millimeter this board. Crazy project. I should actually mark it here. And that's why you leave tolerances. This side is tolerance. I'm not cutting it yet, just because of these little details that I have to keep in mind. You know, I want it like that. I want it like that. Okay, now I like it. It's a bit strange. It's a bit weird, but we like weird stuff, no? Yeah, I like it. I like it. If I like it, it's good. Okay, I'll have to push this tiny little bit back because I'll leave a tolerance here, because I will put a cardboard here. I will glue it on top of this with all those pads. So I have to move it even further, a tiny little bit. I have to take in consideration the thickness of the cardboard plus the thickness of the metal pad here. So it will be glued here with those pads on it. Is this element. It will be on its own cardboard with everything on it and glued, and that's it. That's how I will make it. By the way, I only measured this board. So here in my 3D version, I only measured this entire size of the board, and that's it. The rest I just fit in, like you just see me. I fit this rotary encoder there, and then draw the pads without any calculation. I didn't get the exact size of those pads. I just draw them by hand, and also those. I just eyeball it, and it fit perfectly, pretty much like you are seeing here. You see, in the this pad is in the middle of that line, and is pretty much bullseye, and it's starting from this side here. You see, exactly like that. I took this distance arbitrarily. I didn't just by eyeballing. That's why it's good to be an artist. You have a very good eye for details. These ones are a bit short. That's the only detail that I should correct here. Yep, like that. A little bit more longer. Like that. Interesting, huh? So now I have more space to mount those components. I don't want to get very close together. I like large distances like this. It's very good to have. Okay, now what? Now to add these pads. Yeah, joy, joy forever. One down. All right. Okay. Good for my family. Oh yeah. Hmm. Perfect. All right, it looks like all the pads are mounted. I only have left this one. I probably should glue this here already. Put a little bit of glue. Now, a couple of components to add and wiring. And I'm thinking, smart actually, to add this rotary encoder as the last component, because it will be in the way while I'm building all this. Yeah, I should probably trace all the wiring. Then it's 1, 2, 3, 4 here. And that's 11 at the end. Like that. I have this positive line here to here. And here is under it and is connecting to this pad. Like that. No, not there. Here. So this is plus, and this is also plus. Like that. I should probably make right now this little board here with the pads to actually drag the wires correctly to it. Yeah, and also that one. Yeah, this wiring is very, very helpful when I'm actually wiring, and I can follow the wires that are drawn here. You know what? I could have dragged the wire like that. Yeah, well, from here to there. This shorter wire like that, instead of this longer wire. Actually, it's good this one to show that it's going somewhere there underneath. I have a ton of wires, so it's really not a problem. It will show that it's linked somewhere underneath there. And yeah. And this little module here to put it in there. Okay. It's good to have a middle all the time. Okay. Look at it. Isn't it beautiful? I think it is very beautiful. This is perfect. Excellent. Excellent. All right. Let's see. And on this other side, I will put this. This is already made. I will stick it there. Unfortunately, it is ugly as fuck. So 5 volts, 5, and positive, push. Sometimes you have to write inverse, and here this is 0 volts. Looking very, very nice. I really like it. It is looking quite interesting, but it is an interesting subject. So why not making the board itself interesting? Huh? Do you follow my logic? So this part is finished with mounting the pads. It took me quite some good time. 6:30 right now. Probably like 5 hours. I made it from scratch. I had to calculate everything. So all of this in one day. About 5 hours or 6 hours. I'm not sure what to do next, if I should mount the components or do the wiring and then the components. I don't want to stress the components when I will add the wiring. From the components stress point of view, I will add them. The next part is wiring and then adding the components. Although I did add this component with its board, but I have to wire its pins. So this is literally central processor here, literally. This is the good scrapped wires. It's still scrapped, but it's the good one. It's more isolated, although it's having pockets of disisolation from place to place. So it's a bit of a gamble if I don't catch with that pocket another wire. Hopefully it will be fine. Okay, a bit of isolation, just to be sure it's not touching anything important and making a short. All right. All right, the wiring is done, and it passed only 1 hour and 45 minutes. I'm looking on the camera right now. I hope I wired everything correctly. Hey, shit, I made a mistake. I wired here instead of here. Bloody hell. It's good that I've seen it. It's not good because I wasted some wires. Huh. Motherfuckers. And this was one of the first wires. Yeah, I suppose I can cut this wire. There. I do not like mistakes. But shit happens, and it's good that I've seen the mistake. That I catch it. To be sincere, I am a bit tired. I worked all day like a crazy man. I can afford it because I'm not working. I don't have a job because capitalism is a good thing. Nobody will hire me, so it's fine with me. I believe in capitalism. Capitalism is the shit. Okay. Oh, I made a mistake here on the drawing because I did follow exactly the drawing, and the drawing was wrong. Perfect. Okay. Yeah. How the porn girls are saying, yeah. I'm learning from the best. To make the actual drawing here, to continue this line like this. That is good. It's good in my book. It's good for my family. Yeah, so I did make the mistake in the drawing phase. Yeah, let me check everything if it's correct again. Now all the wiring is done, and now the components. 100 nanofarads here. Actually, I have this legged ones. Can I reach from side to side? Maybe. Yeah, it's
right on the limits, from there to there, perfect. This one with legs is actually saving me from extra wiring, you know. Look how flexible it is, very, very flexible. What do I have here? I have a 10 kilo, and I'm not decided what LED colors I should put there, but small steps, I suppose. No. Ay caramba, it jumped. I believe one wire springed up and it pushed the resistor outside. Yeah, it's very tricky to work here. Yeah, it's alright. That resistor is mounted. Very good, very good. Now the hardest part is what LEDs to put there. I have no idea. Well, this is a cold white. Very shitty angle. Actually, I should prepare it a little bit. Okay, so that is a button press, and I'm thinking either two greens or two blues. So I will use two blue LEDs, the good ones, the normal ones, and the same as before, a little bit of preparation. Yeah, and the final one. Okay, the LEDs are mounted. Yay! Here is 1 nanofarad, that one. Okay, and these are two 10 nano. 1 nano. I think this is scrapped. Yeah. Excellent. Very good. Next, the LED that will react immediately when I'm pressing the button of the rotary encoder is not programmed. This one will be from the program. And what color should I make it? Yeah, that is white. I should probably put a cold white as well. Cold white. It will be weird with two LEDs opening in the same time. I am aware of it, but I will make it as I did it on the breadboard, pretty much. To negative. And my fat tip of the iron is not reaching between those two components. But I have a wire here that I can jiggle it. I'm jiggling the wire while the solder is fluid. And 10 kilo. 10 kilo here. Preparation is always good. Okay, these three components are there, which are those. And now all that remains are this and that. And that's why it's good to have solder collected from boards. This is scrapped solder, and this project eated a lot of solder for those pads, and this scrapped solder is gold. What do I have? 10 nanofarads. Okay, here it is. Here it is. 210 nano. Between the legs, here and here. A little bit of preparation. Yeah, good enough for my family. Okay, so 10 kilo, 10 kilo, 10 kilo, 10 kilo, 4 10 kilo. Okay. Okay, let's prepare them. And this other one here. Okay, and these two LEDs. And again, I'm in a great impasse. I don't know what to use. I don't like it to be multicolor, actually. The hell if I know what color to use. Yeah, I'll use two red, probably. It'll go nice with the blue, probably. I hope so. I have no idea if it will look good or bad. I will prepare everything so it's receiving positive, and here also positive, and is facing towards this part when it will be negative. This is double trouble because I have to align it with this one. Hopefully I made all the connections correct from the design time, and also here. I really hope so. This one, because it's stupid large, I think I can actually take it out whenever I need to make a correction here on the cardboard in the circuit. Yeah, it is perfect. Perfect connections. Very good. Yeah, pretty wild. Pretty wild. I like it. I like it. Holy shit. Now to actually program it, to actually test it. Yeah, I'm very, very curious if it will actually work. Pretty much project finish at this stage. The construction part pretty much is this thing. And I will have to put these wires, probably take them from here and mount them there. Actually, let me do it right now. Yeah. Green. And here white. White with green. Blue 112. Negative here. That's why it's very good to have these little notes everywhere to look and to see exactly where you are connecting. For a second I was tempted to put this negative wire here on the positive for a second, but then I read it and that's positive. Theoretically all the wiring is as it was before, so right now it's ready to be programmed. Let's hope it will do the job. And right now it's very, very flexible, but I will, yeah, you see, but I will glue it very firmly on a piece of wood, very stiff wood. Wish me luck because I worked like an idiot. Right, it is already programmed and I already tested it. So check this out. If I'm pressing the button, it's lighting up these two LEDs. This is electronic contact LED, is responsive electronically directly when I'm pressing the button, but this is programmatically responding. So you see this is having a tiny little bit of a delay. Is I believe it was 500 milliseconds or something like that. But this is, you see, is absolutely back. When I'm pressing and when I'm releasing is there. And now the rotation, and I will do it slowly. So if I'm rotating that way, first this one, press it. That second, that one, it lit up that LED and then off and then off. And this is the sequence towards that direction. And now this opposite right direction, it will lit up first this, second this and this. You see, it lit up that. It will turn off that one and it will turn off this last one. So this is the sequence of the rotary encoder here on the board, and it is displaying correctly in which direction. Very, very, very cool. When you have it in your hand, it is completely game changing when you actually see it working. Unfortunately, what I don't really like about this project is the size of it, because I had to integrate this in-circuit serial programmer board. Of course, when I first tested, I got some errors, of course. When I was rotating from this rotary encoder, both of the red LEDs were lighting up simultaneously. Doesn't matter which direction I was rotating. And I checked every wire, I checked every component. It didn't make any kind of sense. What it was, in the end, here, these two pins, which are actually connected to this pad and this pad, where the two LEDs are situated, these two red LEDs, this one and that one. Somehow I touch these two pads, these little pads, and I made a bridge, and I didn't see it. And I checked everything, and when I was programming the chip, I was getting a very nasty error. Oof, poof, you did something wrong there, you have a bad connection or something like that, or you don't have the right device or something like that. It was the error from Arduino compiler. It took me like probably half an hour or 20 minutes, half an hour to check everything, and then to actually look there, and it was that bridge, fucking bridge there, unbelievable. And that resolved the error that I was getting from the rotary encoder, both of the LEDs lighting up. Let me show you the setup, what I'm having on my breadboard, and how I'm actually programming the chip. Even if it's already programmed, I will do it again just to show. So it is working absolutely gorgeously. I love it, I love it. I also love this long button. It's the only one that it fitted perfectly on the shaft that I'm having there of the button. By the way, I'm powering it with 5 volts from my power supply here. There is my Arduino, there is my testing board, and that's the first ATtiny44 programming cardboard. And this is the new setup. This is the new programming board cleanup from all that stuff. And I'm having these 4 wires on pin very intuitively, actually, pin 10, 11, 12 and 13, and positive and negative from the Arduino board itself, and that's it. So when I'm plugging it in the first time, it is doing a sequence. Let me show you if I'm powering it. 1, 2, and those 2, and that's it. It's powered up. It's announcing me that it's ready. It's like that, you know. So I powered it up with these 2 wires, in-circuit serial programmer, these wires. And right now it is powered, it is functional, exactly on my other table. You see the sequence is exactly like as before. So I actually made a second folder because this was the breadboard test that I did before, and this new folder B is containing the updated file, which I'm having it here already open, and I had to update it with new LED pins and also the new rotary encoder pins, because I changed a little bit from the original that I had before, and that's it. And also I had to change inside the code here, LED 1 and LED 3, and here this is the startup LEDs when it's starting that sequence, when it's first beginning. This is initialization as input, all those pins for the rotary encoder, and this for the LEDs as output, also initialization. And this is the sequence that is doing when it's starting up only one time. Let me actually send the program, so upload, and let's watch here, because here is the most important part. It should not give me any error. Done uploading. Excellent. This is with the new uploaded program, which is the same as it was before. So when I'm rotating, so it overrided the last program, which it was exactly the same thing. And now the pressing button is working fine. So this is pressing the button of the rotary encoder, and this is, again, this is the programming response, and this is the instant electronic response from the button press, as you can hear it. So I'm having practically I'm having this circuit, which is a total novelty. This was the first time when I programmed this particular chip, the very first time. And also the very first time when I tested and made the correct code, absolutely fantastic, working specific for this rotary encoder. I didn't took it seriously, too seriously. But now, after I bumped my head over so many walls and problems with this rotary encoder, now I know better to take it a bit more serious. And that's this circuit is doing, is practically is copying this circuit and this circuit in one single board. That's what I did there. And also I followed that commercial board that is looking way more nicer than mine, but my board is for learning purposes, is for figuring out everything. I didn't want everything to be as small as possible. I wanted a bit more spacey to be able to debug it, to find problems. This circuit, what we are seeing here, is absolutely operational, and I really want to make a real test with it. That's why I put these large pads here where these LEDs are connected, to drag some wires from them and to actually link them to another circuit, and when I'm rotating the knob, to actually command something. I was thinking to command a counter, a chip, integrated circuit counter, but not my favorite 4017. I have another that is having forward and backward. My favorite 4017 is having only one direction, only forward, is counting up all the time from 0 to 9, but not inverse, not from 9 to 0. You know, you cannot turn it back. But I have another chip that is doing exactly that, and it's having two clock pins. My 4017 is having only one clock pin. That's why it's unidirectional. But I will have to search for it and mount it, and that bidirectional chip, I can actually command it from this to direction from the rotary encoder, because it is a single pulse after all. You see, is a single pulse. It's not like here, you know, a code, a binary code that is heavy. This is performing the decoding and is outputting one single pulse, like beep, and that's it. Until is from when it's starting and when it's finishing that step of 4 bits of the rotary encoder sequence. This is it for this project. Project successfully finished, and I'm very, very happy. I am very, very happy for the development, for the project, how I get it done and how it worked from the first try. Let's say it was from the first try. Let's make abstraction of that little problem I had, that I didn't see it, the little bridge on the pins of the actual chip. They're on the board, it was the bridge. But let's say it was the first time running. I didn't have any major problems like rewiring or misplacing components. It wasn't major. It was just a little shit that I had, that I literally didn't see it. I didn't look there very carefully. But let's say it was a success on the first try. And I highly recommend it to other people that are like me, that are fun microcontrollers. They like to do stuff with microcontrollers. They like to, maybe you like to experiment with them, to learn them, to get your hands wet, you know, and your feet wet with them, whatever you want to wet. It's just fun to program them. It's all that I have to say. So until now, I tested these two very extraordinarily new microcontrollers that I never put my hands on them until recently. That Atmega 328 and this one ATtiny44. I really didn't work with them ever in my life. These movies were the first time when I actually put my hands on them, and they are very good, very nice to work. Okay, this is it. Thank you very much for watching. Thank you very much for understanding everything I made and I discussed and I presented here. And if you think I deserve, you can leave a like there and also a comment if you like, and say thank you to your favorite artist electronist, Mr. QTF. So this is it for the construction stage of this board. Totally worked, absolute success, fantastic success, joy forever, seriously joy forever. All right, thank you very much and goodbye from your favorite artist electronist, Mr. Q12. Remember that. Bye bye. Bye bye.